What have scientific studies revealed about Jupiter? Imagine a world so immense that all other planets in the solar system could fit within it. A gaseous giant filled with colossal storms, bright auroras, and over 90 mysterious moons. This is Jupiter, the king of planets, whose wonders continue to fascinate scientists and space enthusiasts. In this video, we'll explore this gas giant and uncover the mysteries that make Jupiter one of the most fascinating planets in the solar system. If you're eager to learn more about this mysterious planet, stay with us, buckle up, and let's embark on a journey of approximately 628 million kilometers to unravel these secrets. Mission 1 of the most intriguing regions Webb has observed is the area above the Great Red Spot, a giant storm already known for its extreme features. However, what has been discovered now goes beyond what was imagined, with the detection of intricate patterns including dark arcs and bright spots, suggesting an atmospheric complexity that had not yet been fully understood. These unexpected patterns indicate the presence of dynamic atmospheric processes that are not visible in other forms of observation. The region, thought to be relatively homogeneous, turned out to be much more complex than anticipated. These structures suggest the existence of gravity waves, a phenomenon where oscillations occur due to density variation in the medium, in this case, Jupiter's atmosphere. These waves likely originate in the deeper layers of the planet's atmosphere and propagate to the upper region, creating the formations observed by James Webb. The presence of gravity waves in Jupiter is not entirely unexpected, but Webb's observations provide detailed visual evidence for the first time in such high resolution. Juno mission has provided unprecedented understanding of Jupiter's magnetic field, revealing features that defy previous expectations. One of the most significant findings is that Jupiter's magnetic field is not only incredibly strong, but also irregular in various regions. The area around the Great Blue Spot particularly stood out, showing an unexpected intensity and magnetic complexity. This irregularity suggests that the dynamic processes inside Jupiter are more complex than imagined, directly influencing the structure and behavior of the magnetic field. The Great Blue Spot is a region where the magnetic field is abnormally strong and disorganized, indicating that Jupiter's internal dynamics may be generating flows of conductive material that create these variations. This discovery is crucial because it challenges previous models, which predicted a more uniform magnetic field. The information provided by Juno is allowing scientists to refine their models of how Jupiter's magnetic field is generated and maintained, offering new perspectives on the planet's internal mechanisms, including the possible existence of a liquid metallic core that might be contributing to these variations. In addition to discoveries about the magnetic field, the Juno mission has also brought new information about the intense radiation belts surrounding Jupiter. These belts are composed of charged particles moving at extremely high speeds, creating a highly hazardous environment for future space missions that may attempt to explore the Jovian system. Detailed gravitational data suggests that Jupiter's core is not a compact and well-defined structure as previously believed, but may be partially dissolved. Instead of a solid core, there appears to be a vast region where heavy elements such as metals and silicon are mixed with hydrogen and helium, forming a gradual transition between the core and the upper gas layers. Until now, scientists believed that Jupiter would have a solid core formed from the accretion of heavy materials during the early stages of its formation, which would later be enveloped by layers of hydrogen and helium. However, Juno's data suggests that the core may have undergone a dilution process, possibly due to intense pressures and temperatures that caused the partial dissolution of heavy elements into the surrounding hydrogen and helium. The idea of a partially dissolved core also raises new questions about Jupiter's evolution and how these internal conditions may influence the planet's global behavior. For example, this unusual internal structure could affect the planet's magnetic field, contributing to its complexity and irregularity, as observed by Juno. Additionally, there may be implications for understanding how heat is transported from the planet's interior to its outer layers, affecting atmospheric dynamics and Jupiter's climatic characteristics. Jupiter's auroras, captured by the Juno mission, are some of the most impressive phenomena in the solar system, standing out as the brightest and most powerful known. These auroras result from the interaction between Jupiter's colossal magnetic field and the charged particles bombarding its atmosphere. Unlike Earth's auroras, which are primarily fueled by solar wind, Jupiter's auroras are also intensified by energetic particles from its moons, especially Io, which ejects ionized materials into space. This process creates a unique luminous display, visible in various parts of the electromagnetic spectrum, including ultraviolet and infrared light. Juno's observations have revealed fascinating characteristics about Jupiter's polar cyclones, showing that these massive weather systems are remarkably stable and resilient. At both poles of the planet, these cyclones not only persist over time, but also maintain organized formations in specific polygonal patterns, an octagonal pattern at the North Pole and a pentagonal pattern at the South Pole. This symmetrical and organized structure is surprising, considering the turbulent nature of Jupiter's atmosphere, where one would expect such formations to be unstable. The stability of these polar cyclones suggests that they have deep roots in Jupiter's atmosphere. Unlike surface storms that can dissipate quickly, these cyclones seem to be anchored in deeper atmospheric layers, giving them notable resilience. This indicates the presence of a complex and powerful atmospheric dynamic that sustains these patterns, possibly involving interactions between deep atmospheric flows and the planet's magnetic field. The polygonal patterns observed at Jupiter's poles also raise interesting questions about the physics governing these cyclones. The organization into regular geometric shapes, such as octagons and pentagons, is rare in planetary atmospheric systems and suggests that balanced forces are at play, keeping these cyclones in their relative positions. This may be related to Jupiter's rapid rotation and internal structure, which creates specific conditions that allow for the formation and maintenance of these unique patterns. The Juno mission has provided new insights into the complex interactions between Jupiter's small shepherd moons and the intense radiation environment around the planet. These moons, which orbit close to Jupiter's rings, play a crucial role in maintaining the shape and stability of these rings. Juno's observations reveal that the interactions between Jupiter's radiation and the dust particles around these moons are fundamental to understanding how the rings are shaped and preserved over time. The small shepherd moons, by orbiting so close to the rings, constantly interact with the dust particles that make up these rings. Jupiter's intense radiation affects these particles, charging them electrically and altering their trajectories. The moons in turn act as shepherds, using their gravity to keep the particles within a specific range, preventing them from dispersing. This gravitational and electromagnetic dance between the moons, the dust particles, and Jupiter's radiation helps maintain the ordered structure of the rings, preventing them from spreading or disintegrating. We've reached the end of another interstellar journey through the solar system, where we've unveiled some evidence about Jupiter. This planet is a world of extremes and wonders, a true giant that continues to surprise and challenge our understanding of the universe. I hope you enjoyed this journey through the storms, auroras, and hidden secrets of Jupiter. If you were as fascinated as I was by this incredible planet, don't forget to like, share, and subscribe to the channel for more videos about the mysteries of the cosmos. Also, check out the video where we talk about the secrets of the Nazca lines. Until our next exploration.